If you don't know how to classify rock slides, that will be a good video for you to watch. We're going to start with this classification, which was proposed in a book by Varnes. This is actually a very good book. I strongly recommend to read it. And the classification was based on the type of movements. So we're going to only look at the bedrock. So let's not look at the landslides yet. And you will see that depending on the type of movement, we can have rock falls if rocks are just falling down. So if rocks are toppling, then it will be rock topple, right? And then when we look at the slides, there's two types that we can consider, rotational and translational slides. And also when we talk about spreads, when we have like something that kind of like really like large and a general angle of inclination, it will be a rock spread. And when we have a flow, which is kind of like very slow moving rock slide, we're gonna call it creep, right? So of course, there are also things like slides when we're not really sure which one they are. So they can be like maybe start as rotational or maybe start as a creep, then turned into rotational slides and stuff like that. So if you don't know that, we're just gonna call it as a complex, and that would be combination of two or even more of these types of. Let's start with the toppling that typically take place in rock mass that have bearing planes, like is shown here, or it also might have just a vertical or like let's call them steep discontinuities, as you can also see here. So what is going to happen if there is not enough friction between this bearing planes, so between these layers of rocks, and they're inclined at a very steep angle. Because of the gravity, they may topple and go this way, and that will be typical example of toppling. When we talk about rock slides, we typically consider two cases. On the left-hand side, we have planar failure. So this is very common for rock mass that has discontinuities that are more or less parallel to each other. So if a failure happens, it happens along one of this discontinuity. Here you will see a tension crack that will give us already a good indication that this rock mass potentially unstable. Another important thing that we need to consider for this type of plan failure that these planes, these discontinuities should come to the surface. So they what we call daylight discontinuities. So on the right hand side, we have slightly different types of failure. So we call it rotational rock slides. It's also common when we have very weathered rocks, like it's shown here, when we have rocks mixed with the soil. So gray material is going to be soil. Because of the presence of soil, this failure plane it's circular. It's not planar anymore. So as I mentioned, something that can happen in a very weathered material when we still have bedrocks or heavily weathered rocks, and we have lots of soil on top. Lateral spread, it's very common for very large rock masses that typically fail during earthquakes. So what you're going to see here, so this site is actually huge, and there are a few things which are common for this type of failure. So first of all, it's a very large landslide. So it can be landslides on rock slides. You will see that most of the time when we deal with the material on the top, it's going to be rocks. So it can be hard rocks or slightly weathered rocks, but they're rocks. But the thing that actually causes this failure is that underneath the rock, bedrocks, we have usually a very thin layer of soft material, which is usually clay. And this is why this large rock mass, which is in general very stable, it tend to fail. So you will see that this is one of the features for this type of rock slide to take place. Another common feature is that this failure plane is very gentle. Usually it's less than 10 degrees. So for typical slides, we would have slopes like this, and we have a failure plane here. But for this one, this what we have is very gentle. So basically, it's we can even call it like almost no failure plane angle. But what is going to happen is that this is rock mass. It's very heavy, and it's very big, and it's sitting right on a very soft material that can be clay, and this clay can be very, very weak. So when especially it's saturated, it can be causing all these troubles, but it may only happen when we have a strong earthquake. So if we have a rainfall, there is nothing is going to happen because this failure plane inclination is usually less than 10 degrees, so it's not enough to trigger any rainfall-induced landslide. It only happens when we have a very strong earthquake. So this is just a good example that I investigated in my career many, many years ago. So this happened in Japan. It's called Aratazawa Landslide. It's one of the largest landslides that probably happen in the world. You will see that this distance is about 1,000 meters. So that's how big this rock slide was. And finally, let's talk about creep. This is also very common in rock mass. It's also common in metamorphic rock mass, like, for example, schist. So, what are the common features of this type of failure? First of all, there is no defined failure plane. So, as I showed you before, if we have a slope and we already have some defined failure plane, and this mass will go down because of the gravity. But for creep, what is going to happen is that we have some kind of like a cracks forming over time, but they are not connecting. So we don't have a defined failure plane. At some point, when this mass keeps moving down because of the gravity, it will finally develop into a failure plane, and then that movement of this rock mass would accelerate significantly. But while it's still in the process of developing failure plane, this is what we call creep. This rock mass is gonna move very, very slowly. Sometimes it's not dangerous because these movements can take years. For example, one of these rock slides that were investigated in Japan, so it was moving for more than 30 years. And still, this part of the slope was stable, even though they did some construction here, excavation there. So it's still going to be pretty safe at some point, right? So the two important characteristics is that there is no defined failure plane, and typically it happens in metamorphic rocks. Why? Because metamorphic rocks has foliation. Foliation is arrangement of minerals, crystals in the rock mass. So because of that one, it typically kind of have areas of where there is accumulation of loss of strain, and this is why this is common for this type of rock mass failure, which is called creep. How we can discover that one? Typically, when we do some site investigation, we can look at a broken fence, like you can see here. We can also see there is all these what we call tree trunks curved or like drunk tracks. So they're kind of moving, and this is part that we can use to identify that's creep.